On to some programming tips for routing. Now in the previous video, you might have noticed my voice was a little echoey. That's because last night I installed these new awesome light bulbs in this room, but I moved my microphone right here into out of the way basically so I could get to that light fixture. But let me tell you about these bulbs, right? These bad boys, look at this. This is a $20 light bulb. The reason I bought this thing is, well, you know, I just figured I'd get newer bulbs and they last. It claims 22 years, so maybe that's fine. Anyway, this is a high color rendering index bulb. Got good good quality reds, so I'm pretty pumped about it. I officially endorsed this bulb. It's pretty cool. So hopefully when I get my sponsorship money from Green Creative, maybe we can, I don't know, I'll throw a party or something with my money. Anyway, all right. So that's my light bulb plug. So now let's talk about routing. In this code, we give you some skeleton code to help you get started with this task. And it's a little different than the kind of skeleton code that you've usually done in 61B. Other programming classes, you'll probably get this happen to you where you get dumped a giant bunch of code and you have to fill in the blanks in the middle. I'm not typically a big fan of this style of programming because it's very artificial. It's one thing to use someone else's library, but it's another to have like an if statement that you fill in. It's just a strange thing, but I think it's the best way to do this. Although the more I think about this project, the more I think that we could have maybe gotten you to build this from scratch. Anyway, enough philosophizing, sure. So what this program does here, this is going to be where you put your code that builds the graph, right? And so what happens then, the way this works is you're going to override this start element method. What this start element method does is it will iterate through your file that we've given you. And basically, there's a thing called a sax parser described in the spec, where it will iterate through each of these tags. And every time it hits one of these lines of code inside a tag, which is something like that, that will mean that start element gets called. Okay, so anytime you hit one of these, start elements gets called, and this information is available to the method. And because you know the sequence in which the tags appear, you can actually build your graph in that manner, right? There's another method that you'll call as well, called end element, that you fill in. And that's called anytime you hit the end of an element. And that's either /way or /node for our project. Though there are also, at the very bottom of the file, some so-called relations. And these correspond to things like bus routes, and I'm not quite sure what else. We could ignore those, though. Don't worry about that. But basically, any tag that goes open brace / that's an end element. And so there's two different methods depending on if we're calling it on, well, actually, I'll get out of the relation zone. So the start element will get called on this line. Oops. What the heck? Okay, it'll get called on this line, this line, this line, this line, this line, this line, and then end element gets called there. That's the flavor of how it goes. So to get a sense of how this all works, to really get it, what I would recommend is uncommenting the print statements that are in the starter code. So I'll just give you an example of what that's like. So if I go into the graph building handler, here are some print statements that apparently get called at some point. And I can start up my map server and see what happens. Okay, when I open map server, we get dumped all this node lat lon stuff. And that'll work. Though I'm going to recommend that, particularly because you've probably already written at this point your rasterer, it's probably slow to build the quad tree and all that stuff. So instead of using map server, I'm going to recommend that you use a GraphDB launcher, which does a very similar thing. It's just a smaller environment where you can interact with your code. So if we do GraphDB launcher instead, when we run this, okay, same thing happens. We print all the lats and lons, but now you know exactly what's happening. This is a main method that you can experiment with, whereas map server, it's much more complex. So this is a simpler environment to get used to it. Okay, so that will give you a sense of what's going on, and we can go to the very top of this executed output. There might be a little too much. Let's see. So let's go into graph building handler and let's set a breakpoint. And now I'm going to run GraphDB launcher. And I see, okay, when it ran, the first thing that happened, I guess I'll go one more line, is we got to node 30362.155. Here's lon, here's lat. And actually, if we go look at the Berkeley OSM file, at the very top, what do we see but 30362.155? So by doing that, you can get a sense of what our starter code is trying to accomplish. And you can, as a result, hopefully get a better understanding of what you're supposed to do. Okay. Now, you could do this however you want, but I think this idea of setting a breakpoint in GraphDB launcher, using GraphDB launcher and using the debugger is the way to go. Okay. I promised myself one take, so whatever weird stuff happens in this video, it's going in. Even my long light bulb rant, which I'm slowly regretting more and more. Anyway, so I want to mention an important point, which is that when you first encounter a way, you don't know if it's going to be a highway, that is a footpath or whatever else, or it's going to be something else. So let's consider the example of Berkeley Bowl. Here's a way. You get to this way and your code says, okay, I found a way. This could be a street. So what that means is maybe I need to add a bunch of edges between these nodes. And so you need to keep track of all of these nodes here because they might be part of a road. You don't know. When you finally get to this building tag, that's when you realize, oh wait, this is not in fact a road. Oh, this should say it's not a highway. It is a building. Confusing. So only when you get to that point do you realize that it's not a highway, and then you could in theory throw it away. Now I want to note that's us, me and you as a human being. If we knew the OSM format really well, we would get to this building tag and we could immediately quit. But for your code, you should not write a bunch of statements that say, oh, this is a building, so don't do that. Or, oh, this is a footpath, don't do that. There's a simpler way, which I'll show on this slide. So let's think about what a valid road looks like in our OSM format. We have our way ID here. This is the unique identifier for this way. There's 5 nodes here. And when we get down here, we see, oh, this is indeed a highway, and it's a primary. That's allowed. And so as a result, the ultimate effect on our graph is that we should be adding edges between these 5 nodes here. So these are the 5 nodes listed. And so ultimately, there'll be an edge between these 2, between these 2, between these 2, and between these 2, for a total of 4 edges. And how do I know that? Well, I know it's a valid way, so all 4 of those edges should get added. So the ultimate effect of processing this way right here should be to add 4 edges to your graph. And so the recommended approach, if you look in the skeleton code, is basically anytime you see things have gone right, you'll make a note to yourself. Okay, so we go here and we say, if the active state is a way, and the thing we're looking at is a tag, right? So this is a tag. And if the name that corresponds with this particular tag, if K is highway, okay, well in that case, as long as V is good, then we're going to make sure to save this. So it says here, setting a flag is good enough. So basically there's a little if statement you can have here that says, as long as V is good, then I'm going to make a note that this way is worth keeping. Now, I think it's probably best. In fact, you could in principle immediately write all the edges to the graph at this point, but it's probably best to wait until you get to the end element. And so this is the place where we recommend that once you are done looking at a way, you have some information. So basically, start element got called over and over and over. You store a bunch of information, and then you get to the end of way, you say, if it was valid, I'll add all of my edges. Okay? And so, you can keep a bunch of information up here and some instance variables to maintain what you know. And again, this is going to seem like a fairly vague challenge, but I think you're up to it. Okay? And it's a really, really good exercise because this is the kind of thing you have to do when working with real data. You use weird libraries, and it could be a little mind-bending. Okay? So I should mention, just in terms of a very general idea, there's a nice little write-up that I linked to on the website earlier in the semester during one of the readings, which is something called Redshirt coding. And the basic idea is you should feel free to write little bits of code to understand what's going on. So, you can put in stuff here and just run your code and see what happens. You can use the debugger and say, okay, I'm going to set a breakpoint here, right? Okay, and I guess I'll take these print statements out. And I'm going to get a sense for what's going on. Okay, I'm just going to run this again. This is kind of like Redshirt coding here. It is Redshirt coding. Okay, so it's running. Have I reached this line? Yes, okay. So I'm going to step forward. And I can see, okay, so I've got K and V, and I get some sense that, okay, at some point I've hit, what else do I know? I don't know if I have the ID of the current way. I guess I don't. But this gives me a sense, okay, so at this point when my code's running, when I get here, apparently I've hit a one-way road. Okay, well, maybe I do an experiment where I just go to my this file and I look for one way. And so wherever one way appears the first time, this should be where my code just ran, because I just ran my code. This is the first time that I have hit highway. Oops. Okay, one sec. This is more interesting to me probably than you, but basically this is the first time I hit this line of code. So the first time that I have the active state as way, we have hit this line. Okay, So while that might not make any sense to you because you're not me playing around with this, that's the kind. I hope the pattern makes sense. Like at that point, I know I've hit this line, and it gives me a sense of how I can experiment and use the OSM, the Sax parser. Okay. Now that said, I would say that while it's okay to just jump in and write code and try stuff out, it is important not to try and guess and check your way to success with this, because you probably won't be successful without the right mental model of what's going on. So if you find yourself kind of like stuck and frustrated, rather than make random changes to your code, like, oh, well, maybe if I move, I've seen people do that with this particular part of the project where they're like, oh, well, that's not working. Okay, well, I'm just going to move this like down here and see if that works. Like, please don't do that. It's just not going to work out well. I would say in that case, take a step back, maybe sleep on what you've been working on, and come back to it later with hopefully a more disciplined approach. So I want to mention two more things. One is there's 3 different ways that you can interact with your GraphDB class. You could use map server, which we did at the very beginning of this video, where you just run it in the context of your large program. There's a GraphDB launcher, which is like a smaller launcher. It's a nicer environment, right? Rather than make your GraphDB and graph building handler classes play in the real world, in this way, they have a smaller universe where you can experiment with them, right? That is, this code you can read and understand exactly what's happening and thus modify it and play around with it, whereas the map server code is generally quite complex and uses a lot of strange Java 8 features you've never seen. And then lastly, we have AG graph building test, which is not here because I don't have the right version of the skeleton, but it is in the official version of the skeleton, and it provides you with some basic sanity checks that make sure things are working. It also gives you some feedback, some targeted feedback. There's some certain common bugs, and so if you run that test, it might say, oh, hey, you did this silly thing. Maybe, if you're lucky. And it could actually also help you understand what you're supposed to do. So you can look at the test to get a sense, okay, that's what that method means. Now I want to mention a couple things. So an earlier version of the skeleton code and the spec, it said that your distance method should return the distance between 2 vertices measured in units of longitude. That didn't really make any sense because, of course, 2 vertices are distant in both longitude and latitude. So just to mention that the code for that should have read. Okay, I didn't actually copy and paste it in here yet. So this is if your code still says this comment for distance, it should, if you repull from skeleton, you should get this comment instead, but I'll put it here. There we go. So it should return the Euclidean distance, and I actually gave a more verbose definition of what that means. Okay? So just be aware that's what the distance method is supposed to do, and it should not be in units of longitude because that is very silly. Okay, one last thing I want to say, which I just realized I didn't talk about at all, which was graph representation. So your graph representation. One of the things you have to decide for this part of the project, and which I kind of forgot to mention in this video because to me it's kind of second nature because I've been teaching this class so long, but your GraphDB class, it should be a graph, right? It stores all the information, and we have a certain set of required methods. For example, you need to return all the vertices in your graph, or all the things which are adjacent to a particular vertex, or the distance between 2 vertices, or the closest vertex to a specific longitude and latitude, or the longitude and latitude of a particular vertex. Those are the 6 things you're required to do, though in order to get routing working, you will need additional methods. For example, you'll need some kind of method that computes the distance between 2 points in space, not necessarily between 2 intersections, just as an aside. So you have to make a decision then, how am I going to do this? How am I going to take care of all this? And that's going to be up to you as far as data structures go. I will mention that you will need to add some methods to this class. You'll need some kind of add node, some kind of add edge. You may have like add way or something maybe to adds a bunch of edges. That's like adds many edges, things like that. So it's up to you to decide how you want to do add node, add edge, add way, or what you want to call those. That's up to you. All that matters to us is that after this constructor is done, all of these methods work properly. And one method you're going to have to fill in, there's one fill in the blank method, you'll need to clean your graph. And it's actually not such a bad task. You just need to get rid of any node that has no connection from the graph. And hint, you can do it by looking at the adjacency list or whatever. And so it's up to you however you want to do it, right? You can use, I mean, the most common thing is to have a couple of maps, right? And I think I'll leave it at that so you have a chance to explore. Feel free to discuss with each other, post on Piazza. But and you can use the exact ideas from the original graph API that we talked about in class. You can use a very similar notion. I don't know if you can use the exact, but very similar. And one last thing I want to mention is that you'll also need a remove node method, which will go with this clean method here. Okay, so let me just take some notes here so that I have a visual. It is your choice how to implement the graph. You need, what is important is that after we use your constructor, that our 6 required methods behave properly. Okay, so those 6 required methods are, we got, well, actually, I guess that's private, so no, okay, here we go. So we need vertices, adjacent, distance, closest, lat, and long. Closest, lat, long. Okay, you can do them whatever order you want, but you just need these 6 methods to work properly. To make these work, you'll need some core graph methods like add node, add edge, remove node, and maybe more, up to you. I guess I should mention one thing. You cannot use the exact thing from Princeton's Graph API. So Princeton Graph API is good for inspiration, but it does not have add node or remove node. Okay, and it's okay. For example, like whenever you do closest, I'll make a quick note. Closest is fine. Linear time closest is fine. So iterating through all the vertices is totally okay. There's no runtime constraint there. And okay, with that aside, I hope this sort of semi-improvised video is helpful to you. And that's it for videos for now. At some point I'll put together an A-star video, but it's very similar to 8-Puzzle. So I don't know that it's truly necessary, but you know, if there's demand, I'll put it together. So that's it for now. I hope you found that useful, and good luck.